Welcome! In this lesson, we will learn about SI units, prefixes, dimensions, and how dimensional analysis helps us in physics. First, the International System of Units, or SI, is the standard system scientists use worldwide. It has three classes: fundamental, supplementary, and derived units. There are 7 fundamental SI units. These include length, mass, time, electric current, temperature, luminous intensity, and amount of substance. Supplementary units are radian and steradian, used for angles. Derived units combine fundamental units, like Newton for force and joule for work. SI prefixes scale units by powers of 10. Here are common prefixes from tera down to atto. A few writing rules. Unit names are lowercase, symbols for units named after people are capital, symbols are never plural, and we do not use periods after symbols. Now, let's talk about dimensions. A derived quantity depends on fundamental units. We use square brackets to show this dependence. Example, gravitational potential is energy per unit mass. Energy is force times displacement, so the dimension of potential is length squared per time squared. Electric capacitance is charge divided by electric potential. That gives the dimension of capacitance as mass to the -1, length to the -2, time squared, charge squared. Dimensions help us check equations. For example, for the speed of sound in a solid, v equals square root of y over d. The dimensions on both sides match, so the equation is correct. We can also derive relations. Suppose the pendulum period depends on mass, length, and gravity. Dimensional analysis shows the mass exponent is 0, and the period is proportional to the square root of length over gravity. Dimensional analysis helps in unit conversion too. For force, 1 Newton equals 100,000 dyne. Finally, 2 limitations. The numerical constant cannot be found from dimensions, and the number of parameters cannot exceed the number of fundamental dimensions. That wraps up SI units and dimensional analysis. Keep practicing, and you'll get very fast at checking equations and deriving relations.